Relax. Take a moment, grab a coffee, some tea, or just sit back and listen. Because what you're about to hear isn't a story about aliens, at least not directly. It's a story about signals, about noise, and about how sometimes the universe seems to whisper back when we're listening too closely. If you enjoy stories where science slowly turns into mystery, take a second to like this video, share it with someone who enjoys thinking about the universe a little too much, and leave a comment at the end with your theory. Now, let's begin. Here's a simple question. What does space sound like? The common answer is nothing, because space is a vacuum. No air, no sound waves, no noise. But that answer is misleading, because while space doesn't carry sound the way air does, it is absolutely filled with signals. Radio waves, electromagnetic radiation, energy moving through the universe at the speed of light. And for over a century, humans have been listening. We point antennas at the sky, we tune our instruments, we filter out noise. And occasionally, we hear something we can't explain. These are known as ghost signals, not because they're supernatural, but because they appear suddenly, repeat no clear pattern, and then vanish, sometimes forever. One of the strangest cases began not with astronomers, but with radio operators. In the early days of long-distance radio communication, operators noticed something odd. Between normal transmissions, they would hear bursts of static, repeating pulses, rhythms that didn't match any known source. At first, they blamed equipment, bad wiring, atmospheric interference. But then the patterns repeated across different receivers, in different locations, at the same time. Which raises an interesting question. How do you tell the difference between noise and a message? This question sits at the heart of modern astrophysics. Because noise is random, messages are structured, and structure implies intention. Fast forward to the space age. NASA launches satellites, probes, and deep space listening arrays. We build radio telescopes the size of cities. We monitor frequencies that natural phenomena rarely occupy. And then we detect something. Short, powerful bursts of radio energy. Milliseconds long, incredibly intense, coming from outside our galaxy. They are now called fast radio bursts, or FRBs. Here's the strange part. When they were first detected, no one believed they were real. Scientists assumed they were equipment glitches. After all, the signals were too strong, too brief, and too distant to make sense. But then they happened again, and again, and again. Different telescopes, different countries, same phenomenon. So now we know this. Something in the universe is producing enormous bursts of radio energy, and we don't know what. Some FRBs repeat, others don't. Some come from galaxies billions of light years away, which leads to an obvious question. What kind of natural process can release that much energy in that short a time across intergalactic distances? Scientists proposed explanations. Collapsing stars, neutron star collisions, magnetars, dead stars with magnetic fields so strong they can strip atoms apart. And many FRBs likely do come from these sources, but not all of them, because some signals behave oddly. A few repeat in regular intervals, almost like a heartbeat. One signal repeats every 16 days. Think about that. Natural processes can be periodic, but precise periodicity over years suggests stability. Which brings us to the uncomfortable thought. Stability implies control. Now, NASA and other space agencies are very careful with language. They don't jump to conclusions. They avoid speculation. But scientists are human. And when something doesn't fit existing models, curiosity kicks in. Which leads to another famous case. In 1977, a radio telescope in Ohio detected a signal so strong, so clear, and so unexpected that the astronomer monitoring it circled the data and wrote one word next to it: wow. That's where the wow signal gets its name. It lasted 72 seconds. It came from the direction of the constellation Sagittarius. It matched the frequency hydrogen emits, often considered a universal frequency. And it never happened again, despite decades of searching. Now ask yourself this: if you were trying to get someone's attention across the universe, wouldn't you pick the frequency everyone is watching? NASA doesn't say the wow signal was intelligent, but they also can't say it wasn't. Which brings us back to ghost signals. Because NASA has detected radio emissions that don't repeat, don't match known cosmic events, and don't behave like noise. They appear, they vanish, and they leave behind data that doesn't fully explain itself. So what are the possibilities? Let's start with the most comforting one: unknown natural phenomena. The universe is old, very old. We are discovering new astrophysical objects constantly. Pulsars were once a mystery. Quasars, too. At first, pulsars were jokingly labeled LGM, little green men, because of their precise pulses. But they turned out to be rotating neutron stars. So history teaches us caution. But here's the problem. Some ghost signals don't behave like pulsars. They drift in frequency. They change intensity in ways that don't match known models, which forces us to consider another possibility: artificial sources. Not aliens waving hello, but technology. Now pause. Technology doesn't have to be friendly, or communicative, or even intentional. It could be leakage. When we transmit radio waves into space, TV broadcasts, radar signals, satellite signals, they spread outward like a bubble. Any sufficiently advanced civilization would do the same. And those signals would look messy, fragmented, intermittent, hard to interpret. Exactly like some of the ghost signals we observe. Now here's where things get really strange. NASA has detected signals that appear to come from nowhere. Literally. They don't align with known celestial objects. They don't follow predictable paths. Some appear to originate from empty space, which raises a deeply unsettling question. Is empty space actually empty? Quantum physics tells us no. Even a vacuum is a boiling sea of virtual particles, energy fluctuations, temporary existences. And some physicists speculate that under extreme conditions, energy could convert into detectable radiation. But speculation is not explanation. Another category of ghost signals come from much closer to home: Earth itself. NASA has detected radio bursts that appear to originate from below the horizon, from inside the Earth. At first, this sounds impossible. Radio waves don't pass easily through solid rock, but these signals do. One hypothesis suggests exotic particles, neutrinos, interacting with the Earth in unexpected ways. Another suggests unknown atmospheric effects. But again, no definitive answer. Which leads to an important realization. NASA doesn't hide these signals. They publish the data. The mystery isn't secrecy, it's interpretation. And interpretation is where humans struggle. Because our brains are pattern detection machines. We see faces in clouds, messages in noise, meaning in randomness. This phenomenon is called apophenia. So scientists must constantly ask themselves, are we discovering something real or inventing significance? But then consider this. Some ghost signals have been independently detected by multiple observatories. Different instruments, different teams, same anomaly. That reduces the chance of error and increases the discomfort. Which brings us to philosophy. What would it mean if one of these signals were artificial? Not a greeting, not a warning, just evidence. It wouldn't mean invasion or contact. It would mean we're not alone. And that idea, while exciting, is destabilizing because it changes context. Suddenly, human history becomes a local story. Our conflicts become small, our uniqueness questionable. So institutions move slowly, not because they're hiding something, but because implications matter. Now flip the question. What if the signals aren't meant for us? What if we're eavesdropping? In a universe potentially filled with civilizations, communication wouldn't be directed at a primitive species that just discovered radio a century ago. We'd be background noise, which means ghost signals might not be messages. They might be traffic, infrastructure, beacons, or something we don't have a concept for yet. Think about trying to explain Wi-Fi to someone in the 1800s. They'd detect patterns, fluctuations, invisible forces, and invent explanations that feel mystical. That's us, right now.